Okay, everyone, thank you again for joining today's ACCE webinar. It's titled Leveraging Standardized CMMS Data to Collaborate Towards Smarter HTM Decisions. Today, the bulk of our presentation will be given by Matt Baratic of Baratic Engineering, Inc., but he will also be joined by of PartsSource. We want to acknowledge that we are so grateful for PartsSource sponsorship of this webinar. We are very grateful. And a little bit about myself. I am your moderator today. My name is Keisha Brooks, and I am a biomedical engineer at the West Palm VA. I've worked at several VA medical centers across the country, and I currently serve as the secretary of ACCE. I also graduated from Mississippi State University and the University of Rochester. So all attendees will have their microphones muted during this presentation. Questions to the panelists must be submitted in the Q&A feature on Zoom. You can also send me a message in the chat window if you would like a question submitted to the presenters. You can also use the chat feature to communicate any urgent issues directly with me. And please remember to complete the webinar evaluation after attending. The link is provided at the end of the presentation. So a bit about our speaker. Matt Baratic has four pretty big focuses. For clinical engineering, his focus was to improve patient care through cost-effective management of medical technology, including assistance with accreditation and regulatory compliance. Forensic engineering, where his goal is to identify the root causes of adverse incidents and avoid recurrence, including litigation support and expert witness services. His recent publications are the Medical Equipment Servicing Guide, AEM Program Guide, CMMS for HTM with Cohen, and Electrical Safety Manual. He's on the editorial board of Global Clinical Engineering Journal, NAFE Journal 24/7, and ASHE Publications. He's a founder, past president, and fellow of ACCE. We're also joined by Rob Mayer of PartsSource. He has cross-functional experience in healthcare IT, connected medical devices, infusion pumps, and surgical instrument tracking at some of the largest and most innovative medical device companies in the world, including GE, BD, Hill-Rom, Siemens, and now PartsSource. He has an MS in Information Technology from Northwestern and a BS in Electrical Engineering from the University of Illinois at Chicago. And I'm going to pass it over to Rob so he can tell you a little bit about PartsSource.
Thanks, Kamika, and welcome this afternoon or this morning, wherever you are. At PartsSource, our goal is to enable our stakeholders to best serve the healthcare community and ensure healthcare is always on. We aim to do so by providing quality products, services, and solutions to assure equipment uptime. And we encourage integration with applicable software applications, including CMMSs, ERPs, and others via an open API technology, really to help consolidate data and expedite procurement processes. Many of our health system clients are able to streamline their procurement processes, saving time and associated costs using our solution integrated with their CMS and other solutions. Today, our featured presenter, Matt Baratic, will share ways to leverage your CMS data. Next slide. So a little bit about the session today. So if you think about it, while CMS systems are essential for HTM program operations, frontline professionals sometimes regard their interaction with CMS as an onerous data entry chore. And many HTM managers struggle to derive useful insights from mountains of data. Sophisticated CMMS databases allow the collection of vast amounts of data and offer the promise of providing actionable management information. However, with hospitals all collecting data in their own unique ways, it's become almost impossible for HTM professionals to assess their industry as a whole. Discover how 6 competing CMS suppliers recently set aside their differences to standardize how medical device information is configured, and then outlined a method for optimizing and standardizing for failure codes in a recent white paper. You can become stronger contributors to the HTM community and to your own HTM department success by leveraging your CMMS data and utilizing standardized information when applicable. Now I'll turn things over to Matt to continue with the presentation. Thank you.
Oh, thanks, Rob. Thanks, Kamisha. It's great to be working again on an educational program with ACCE and with PartsSource, both of these organizations I've worked with many times in the past, and am always impressed by the dedication to supporting the HTM community. I'm also really happy to see so many people are signed on for this presentation, and it's going to be recorded, so maybe some other people will see it as well. On the list, I see a lot of people I know and a lot of people I don't know yet. And as someone who recently got his second COVID vaccination, I am eager to return to seeing people in person and shaking hands and meeting new people. So I hope all of you are on a good track to achieve that status as well. So I'm going to talk about a particular project that I've been involved with, standardizing the failure code field in the CMMS. But along the way, what I'd like to do is talk about some reasons behind that work and what you can do with it, and just some general principles about how we can make the CMMS more responsible, more useful to everybody involved. And the heart of where this standardization effort got started is with regard to benchmarking. So benchmarking is about, of course, how am I doing compared to other peers in the healthcare systems, and looking for ways, opportunities to improve. You know, it's not so much a negative thing, I'm doing worse than other people, it's that here's something I could probably do better. And as it turns out, I think many of you know who have tried to accomplish this, it's hard. We all in the HTM community do things differently. And so it's hard to compare what I'm doing to what someone else is doing. And there have been efforts to try to standardize. And there are different kinds of different ways people have approached it. I mean, one of the ways is people argue about it and have flame wars about it. And I would call that the bottom-up kind of approach to standardization. There's also been a lot which has not worked very well, although it's entertaining sometimes. But there's a top-down approach that we often use in our profession, where we get together a group that standardizes and creates documentation to roll out to the community. And unfortunately, too often, those get ignored because, you know, my program is special, so I have to do it my own way. We tried a different approach with this in this project, where we decided to not do bottom up or top down, but just sort of sneak in from the side, and it worked pretty well. So I want to show you that, and maybe it's a model for some future activity. I want to highlight the comments on the right-hand side of this screen. One of the things that's frustrated me, and probably many of you, is that the way we do performance monitoring, the metrics we have to keep track of, the documentation we have to engage in, gets defined by regulatory agencies. And so we're not the ones saying, you know, we know how HTM works and we should be more proactive. My opinion is that some of the reason that we're not able to be proactive and not able to push back on some of the regulatory agencies is that we're not united. We can't say, Joint Commission, here's another way to go at that. We want to have high quality, but we'd rather give you different sorts of information. Right now, we can't say we, the HTM community, have a single way of doing things, and so it's hard to push back. So underlying all of this is an interest in trying to let us be able to speak with one voice. A lot of what you'll see today talks about AEM programs, or alternative equipment maintenance programs, and that's an opportunity, but again, we don't have any national resource that we can go to about AEM type decisions because we don't collect data the same from one place to another. So AEM is an opportunity that we can take advantage of as we develop some standardization. So we decided let's try something different. Let's build some standardization and see if people want to take it on. Build it, and maybe they'll come. Seems like maybe they are. So next slide, please, Kamisha. I won't tell the whole story, but back in 2019, the last time there was an AME meeting in person, we had an unofficial meeting where we just called together the representatives from the leading CMMS suppliers, and you can see their names down there, and I'm sure you recognize them, and probably the majority of people on this call use one version or another, unless you have your own proprietary or internal system. But these are the commercially available CMMS packages, and they're different products. You can see on the right-hand side of this screen, some of these companies have multiple offerings. And said, how about working together? And got good support from all these representatives and got support from AME to sponsor this work and put together a charter and that AME officially accepted. And we've been working along on that quite steadily since that time. We're looking forward to having a presence at the 2021 AME Exchange, which we've just heard is going to be virtual rather than in person, one more year only, we hope. But we're going to be well involved in that. So next slide. I mentioned that we're going to be involved because we really see this as an ongoing effort, and we want to have regular reporting, if you will, to the HTM community. So why do we decide to look at the failure code field? I mean, there are lots and lots of fields, obviously, in CMMS databases these days, and we're not trying to make the CMMS packages identical to each other. We're just saying, you know, there are a few areas that would benefit from some standardization. When we talk to the CMMS vendors, they would say, you know, we get calls all the time from our current and potential customers saying, I want your product, just set it up using best practices. And they say, we don't know. Our response is, we can set it up any way you want, just tell us. So there's that sort of communication opportunity there to say, well, yes, dear customer, we will set it up any way you like, but here's something that we've got some consensus on. and we would recommend that you try this. So we picked failure code fields because, so some of the key points are along the left-hand side of this slide, where AEM program decision making. So AEM, and we'll get into some detail about that, but if you want to make decisions about maintenance procedures, PM procedures, you've got to have some data to work with. And so we wanted to make sure that the failure code collected the kind of data that was relevant to AEM decision making and to PM performance monitoring in general. I'll come back to that in some detail, but I want to mention here on this slide, the third point over there, equipment replacement planning. We all have to do that. We have to anticipate as much as we can replacement of equipment, and knowing how things are failing and why they're failing and which kinds of equipment are failing, all is useful information for that kind of replacement and planning new equipment as well. We also want to be able to have some feedback from to designers and manufacturers about what we're seeing in the field. I see we have on the call here a representative from the FDA who we've been talking to, who's is also interested in getting information about medical equipment failures in a more standardized format, so that they can aggregate data and feed it back and follow up their responsibilities in post-market surveillance for medical equipment performance. So some of the things we did are on the right-hand side of this slide. We looked at lots of data sets that were provided by the CMMS vendors. And one particular one I want to emphasize is some work done by Superior Analytics, which is associated with Phoenix Data Systems, that creates the AIMS software package. And Superior Analytics collects work order data and other CMMS data from a huge variety of different organizations, including not just AIMS, but others as well. And so Doug Brown from Superior Analytics looked at 2.5 million work orders and from various sources, and did some analytics. So one of the things we found right away was in the lower, the next set under there is almost everybody had some field that was called something like failure code, result code, reason code, all kinds of things. Some CMMS packages have multiple fields that kind of collect failure data. But one of the first things we noticed was the whole collaborative, I really should say, we had representatives from each of those vendors, and this is work that Carol Davis Smith and I coordinated along with Danielle McGeary from AMI to coordinate and facilitate this work. So we said there are a lot of things in there that have nothing to do with failure. And so, for example, cannot locate device in use. Absolutely, we have to keep track of that, because that's the number we use when that's data we use when we're calculating PM completion percentages. But it's not a failure. So our thought is that goes in a different field. It doesn't go in the failure code field. And you can see some other things that are very useful pieces of information to track. But it's not about failures. And so the first thing we started out with was to say, we're going to recommend using the failure code field just to record equipment failure types. So next slide, please. So we set out some rules for ourselves in how we decide what are the choices that we could put into failure code. And you can be imagining now it's sort of a drop-down list. What's on that drop-down list when you're completing the work order and you're filling in the failure code field? So one is there's a straightforward definition. What is the purpose of this field? What should be in it and not in it? But not so lengthy that it's burdensome to, say, frontline service personnel who are trying to track, deal with this. So the next 2 points are kind of wonky. So field choices have to be exhaustive in the sense that the list of options has to cover every possible situation. So that if you do that drop-down list, you will find somewhere on that list your situation. And particularly if we want to make this failure code field a required field, you have to give it an answer. So you need to make sure that there's an answer that you can pick from. So exhaustive, and the other is mutually exclusive, meaning basically those choices don't overlap. So you don't have to puzzle over that list and say, well, it could be this, it could be that. As much as possible, try to define those clearly. So, oh yes, it's this choice. We also need to have a limited number of choices under that field. Otherwise, it's just really burdensome for frontline technicians, and also means that you tend, when you make people work too hard, they tend to take the easy route and you don't get useful information. I did a HTM program assessment for a hospital system that had a failure code field, and there are 56 options in their drop-down list. So they had every code and letter and number and a few funny symbols that were used to try to accommodate that list. Now, you can guess what happened. Out of those 56, the top 2 in the drop-down list were accounted for 60-some% of the answers. So what that means is the data in there are not worth very much. And so again, keeping in mind, particularly the last bullet point on this slide, is that you're not, if you got bad data, you're going to make bad decisions and annoy the people who have to fill in the data anyway along the way. But what we're trying to get to is, can we get useful information out of the CMMS? And so we tried to keep all of these principles in mind as we went through this process. Next slide, Kamisha. By the way, Carol Davis Smith is the one responsible for the formatting of these slides. And I point that out because if it was just me, they'd be really simple, but she makes some nice slides that even I like to spend time looking at. So this was the early data when we proposed some failure codes, and I'm not going to go down the whole list of them because you have already downloaded or will be able to download a so-called white paper for free from AMI that details this and provides some additional detail about the process. But it's a list. I think there are 14 on here, and it focused on what are the things that are worth keeping track of. We did some testing with people on a webinar, did some polling and said, is 14 too many or too few? And it seemed kind of okay with people. What were we seeing? We're seeing, for example, the things at the top, component failure. We could have just put component failure, but what we saw in the sample data were that batteries were probably the most common single type of component that failed, and it was important to keep track of those separately from other kinds of component failures. So we tried all the way through to, again, have an exhaustive and mutually exclusive list. I would love to get your feedback now or after the webinar today to about what you think. You know, does this really cover it? And when you look at that white paper, it includes not just these lists, it gives you definitions and examples of these, all with an intent to try to make it clear and understandable to the people filling in the work orders. And next slide, please. So I want to talk a little bit about AEM programs because I see this as one of the really immediate and good payback kinds of applications of this material. And this is going to be taken from this guide that's some going on 3 years old now. So, but this is available not for free from AME. But I think at this point, almost all of us are doing some kind of AEM program, although I see there are some of my Canadian colleagues on the attendance list who say, we don't care about AEM programs, but maybe there's some principles that are useful within that. It's AEM specifically is pretty much a US focused thing, but maybe some useful things in here. So let's go to the next slide. On it, I want to do some definitions from the book just to get us focused here. AEM, alternative equipment maintenance, is a way to, while meeting accreditation standards, deviate from manufacturer recommendations for medical equipment maintenance, for PM. And we all know there are plenty of cases where manufacturer requirements are over the top. And so reducing our workload to an appropriate level makes a lot of sense, but we need to have some way to think about that so we don't just do it because, well, I don't like doing that, so I'm not going to do it. Or we've always done it that way and it was okay. But so have some consistency. And so the main objective is to make sure that you, to find ways to reduce time and cost, and while maintaining compliance and maintaining the safety of the programs, our PM programs. Of course, while we're saving time and money, we obviously don't want to reduce the safety of the equipment. So how do we do that? And that's really the gist of what I want to talk about in the next few slides. Next slide, please. So when I say PM, I mean planned maintenance. I think you'll see why I tend to shy away from preventive maintenance because a lot of what we do doesn't prevent anything. But whatever you do, PM is scheduled maintenance, things that we, so CMS and Joint Commission and the accrediting organizations divide that into PM activities, meaning what we do, the steps on the PM procedure, and the PM frequency, which is when we do it, which could be on a calendar basis or it could be on runtime hours for a ventilator, or however it's appropriate to decide when we do some kind of a PM procedure. Next slide. There are two kinds of PM, and this is not my work, but there's some people like Malcolm Ridgway and others that have been careful to distinguish these. There's device restoration PM, and that is things we do to get the device back into its good condition. We restore it to good function, safety and function. And to me, that's true preventive maintenance in the sense that if you fix things up, they are going to break less often. If you replace the battery before it goes bad, it won't fail when it's being used on a patient. So very important kinds of work. And then there's safety and performance verification, which doesn't, as many of us have noted in our work, doesn't prevent anything. It just lets us look for, say, hidden failures or latent failures that could be lurking and could potentially cause harm to patients particularly. For example, the output of a defibrillator that is lower than it should be. And the staff may notice that there's a problem, but their response is to turn it up and hope it works. It's our people who can go out with special training and special test equipment and verify that and find those lurking problems. And so actually, if you examine the PM procedures from manufacturers, almost all of them are safety and performance verification kinds of things. Does the upper occlusion pressure sensor of this infusion pump work properly? Things like that. So it's actually the bulk of the work we do. But I put this up to clarify some of the decision making we have to do, which is on your AEM, you could decide to modify or eliminate any of those steps in the PM procedure if you have data to support that decision, and if you can have some way of monitoring the performance of your program, so that if you make a bad decision, you go too far, you cut out too many steps in your PM program, you switch all of your PMs from once a year to once every 10 years, you want to know right away if you've made a mistake. And so performance monitoring for PM becomes critical. Next slide, please. So this is an element of performance from the Joint Commission standards, and it goes blah blah blah, and you must have everything in your inventory handled by manufacturer's recommendations or an AEM program. There's no third option. There's no, well, we always did it this way. So you either follow the manufacturer by the book, or you put together an AEM program. And I want to focus on some of the things that it means to have a fully compliant AEM program. So next slide, please. This is curious. It's in a footnote of that element of performance. It says, putting something in an AEM program doesn't reduce the safety of the equipment. And I've done a lot of teaching around AEM program implementation, and I always ask the people in attendance, and I will ask you, you don't have to give me an answer, but you can be thinking about this. How do you know? How do you know how well your PM program is working? It seems like we would want to have been doing that all along, but particularly if we start tinkering with the manufacturer's recommendations. Tinker is not the right word. We're using engineering experience and professional judgment to adjust or modify manufacturer recommendations for PM. We sure as heck ought to know whether we're causing a deterioration in the safety or performance or effectiveness of the equipment. So how do we do that? Next slide, please. So how do we measure equipment safety for the PM program? Next slide. Thanks, Kamisha. People keep track of a variety of metrics. When I ask, how do you keep track? These are the kinds of answers I get. Are there patient incidents with a particular kind of patient? That's good to keep track of, absolutely. But they are fortunately pretty rare. And so it's not a very timely kind of, and certainly not a proactive sort of metric for catching poor quality PM or deterioration in our PM quality. There's also different data that people collect, downtime, availability, and which just focuses on how many hours of downtime relative to how many hours of uptime you need. And I think every program should be calculating something along these lines because they are important. The next slide. You can look at failure rates and sort of an elaboration of failure rates, the mean time between failures, MPBF. And your CMMS software can probably be configured to calculate that automatically for a particular piece of equipment or for a particular group of kinds of equipment or for your whole fleet. And it's a good kind of measure that is quite standardized across different service industries, not just healthcare. And so another opportunity to learn from our colleagues in other fields as well. Okay, MPBF, next slide. MPBF gets calculated something like this. And it looks at the devices over some period of time and then has a denominator of the failures of all different types and every kind of failure that you can imagine. And that's useful. I would recommend everybody calculates MPBF, but we know that some of these failures are not going to be mitigated by better maintenance, better PM in particular. If the problem is that there's a device that's difficult to program and people tend to misprogram it, then you can PM it all day long and you won't solve that problem. So there's a reason to distinguish PM-related failures from other kinds of failures, and that's where there's some consensus building. Next slide. Sorry, I got one slide ahead of myself. Kamisha was following me. I messed this up. I apologize. So you have to count failures accurately. So that means you have to have some kind of a failure code field that includes just failure data so that you can get a good calculation of MPBF. Next slide. So a different approach is to also calculate MTBF for PM-related failures only. And the only difference in this calculation is that the denominator is PM-related failures only. So next slide, we'll talk about what I really mean about that. So PM-related failures are of two kinds in the way we've been thinking about it. They're failures that could have been prevented by better PM, like the infusion pump battery failed early and earlier than getting to the next PM procedure. So we want to identify that with a failure code that lets you focus in your responses. It's also about hidden failures that could have been discovered by better PM, like low defibrillator output. So in that list of 14 failure codes options, we wanted to identify some of those as being PM related and some of them as not PM related. And the reason is that once you've done that and standardized on that list, you can calculate not only MTBF, but mean time between failure of PM related failures. And so that is going to let you focus in on deterioration in your PM program. It's not going to, you're going to have a metric that's not going to be cluttered up with failures that have nothing to do with PM. It's going to help you focus your performance metric on only things that suggest a place that we should focus our efforts on improving PM. Not always can you solve it, but you can make it better and you can be aware of it. And one of your options would be to maybe back off a little on your PM and say the changes you made in your PM procedures. So, I cut it back to only from 4 times a year to 1 time a year. Maybe I should just go to 2 times a year. But it I think you see the point here that if we have some automated way for the CMMS to start raising flags that say, here's something you ought to look at, hey, HTM leader, you should at least take a look at this. And that moves us maybe a baby step or two closer to being maybe not proactive, but less reactive. We catch things earlier, and we can use that information to guide our program. So that's the objective. So let's go to the next slide. So the only difference here is that if you're calculating MPBF for PM-related failures, you need to count not just failures, but you need accurate classification of the failure types. So next slide. So where are we at? There is this CMMS failure code white paper that's available. There's the link. I think it's also in the announcement of the link for this webinar. You can certainly contact me or contact ACCE and get that, or just go onto the AME website and look. It's there for free. If you're at all interested in this topic, please get that, read it, and give some feedback. This is ongoing work. So we're the greatest source of wisdom on this kind of material, this kind of standardization, is the people on this call, people who are out there doing the work. What has happened since that was published last year is that the CMMS suppliers have been working on this. They've found ways to implement it in their CMMS databases. They have they offer it to new clients that come on board, and have reported that the new clients generally will say, yeah, I'll start with that. I don't have a better list. Let's use that list. And current clients, they're developing some tools to help transition, some data mapping tools to allow standard transition from whatever codes they're using now to the standard set of codes. So that's work in progress and has some is gaining some traction, particularly with new clients. So phase 2, that was phase 1. Phase 2, we're going to standardize some additional fields, and we are have started that. We've had a couple of meetings. We got the band back together. We got the collaborative group back together, and Amy is continuing to sponsor, and Carol and I are continuing to facilitate. And we are working on, I'll let the cat out of the bag, and maybe surprising at the beginning, we have decided to work on standardizing work order types. And it seems surprising in the sense that, well, heck, we know what those are. And it turns out if you do the same kind of analysis of real world data set, there's PM and there's CM, corrective maintenance or repair, and then a whole bunch of other stuff, some of which makes sense, some of which doesn't quite make sense to me, but it's things that somebody found useful in the real world to categorize. But it's the same situation. We really can't say what are people doing, and they tend not to accommodate things like the project work that we do, or the IT or cybersecurity related activities that clinical engineering does increasingly large amounts of. And so we're just getting started. We'd love to have comments come back about that, but we will, before long, have another webinar. Keep your eyes out for it. That will be through Amy, where we'll tell you what we've figured out so far. We'll ask some polling questions and get your feedback, and we're on our way into phase 2. We are, and this is the last thing I'll say before we go to Q&A. We would love to get publication of how it's working. And that can be, you know, your local biomed society or a formal publication to just say, here's what worked, here's what didn't work. The more we can roll that out to the HTM community, the more we're going to learn from each other. And that's really what it's all about. So I'm going to stop talking here and turn it back to Kamisha to run the Q&A.
Sorry there. Hi, everyone. Don't forget to submit your questions into the Q&A. We've got a couple that came in earlier. We have one that says 14 failure code. Well, the next two questions seem related. So 14 failure codes seem to be too many. 5 or 6 max will yield the most actionable data, the 80-20 rule.
A great observation. I'm a big fan of the Pareto principle or the 80-20 rule. So there's a philosophical issue in there. If you're going to make the field required to be completed, then you got to cover 100%, not just 80%. And so that's a decision you could make. You could just put the shorter list and cover 80. I don't have anything seriously to argue about that, but that was a decision that we made. I'd love to get feedback from people who try to use those, or send your own lists. I would love to hear about that.
We have another question that says, it appears a few of the codes overlap regarding no failure found, no failure diagnosed, no failure on work order. Could you please explain the distinction between the three? Thank you.
I'm going to have to look back at that. That is one of my Canadian colleagues, and I thank you for staying with it, even though you don't have to worry about AEM programs. So I'm not. There's a no failure found list, and I'm sorry, I'm not following it. No failure associated. Martin, that's excellent observation. I'll tell you what. Let's get a copy of that AME document, read that through, and get back to me, because if that's I think there's some clarification in there that would make that clear. So no failure, the detail behind it, no failure diagnosed, now I remember, is the thing came to us broke and we didn't bother trying to figure it out, we just threw it away, sort of choice. And the no failure on the work order is there wasn't a failure. If it's a PM or some kind of work we thought there was a failure, turns out there wasn't. But I agree that if you just look at those 2 or 3 sentence phrases, that it can be confusing. So great feedback. Take a look at the report and see if that clarifies it. But I would love to get your feedback on that.
Okay, we have another question. It says, great presentation. So you're getting a lot of kudos today, Matt. What about the cost of service ratio? Is it still considered a reliable tool?
Oh, I'm a fan of cost of service ratio. That's if you take some set of equipment, you add up all of the costs of maintaining it over a year and divide by the value of the equipment. And I think it's a good one for overall, how are we doing in our program. It's also good for looking at, say, a particular type of equipment that you might want to put under service contract. It's even useful for a single piece of equipment to see if there's a problem with that. Some of the problems with cost to service ratio are making sure that everything in the numerator captures all of the real costs. Turns out one department in one department in one organization and department in another organization may include different numbers. Also, there's controversy about what goes in the denominator. What's the value of that set of equipment? Is it the purchase price, or is it the depreciated price, or is it the list price? Or but most people use purchase price just because it's the one we're most likely to have access to. The others are more difficult. So I'm sorry, I ran down a rabbit hole. Cost to service ratio is great. It's a lagging indicator, I would say, rather than a leading indicator, in the sense that if my PM program went too far and caused some deterioration in performance or safety of a type of equipment, it probably doesn't show up in my cost to service ratio number for a while, quite a while, months at least. And so absolutely we should calculate it. I'm eager to get something a little closer to the real time in monitoring the program. Some of that work actually came out of a consulting job I did with a hospital system, and they were saying, we collect all this data and we, follow all the recommendations for managing our program. In fact, they did. They had an excellent clinical engineering program, but they said, we got caught, we think, behind the 8 ball on some problems that were occurring. And it turns out it was not because of their PM program. It was just that they said to me, all of our indicators are lagging instead of leading. So how can we move a little closer forward? And it turns out that being able to use something like that, mean time between failure, and especially the PM related one, which tells us what we can actually impact as HTM professionals, help them catch things a little earlier. So that's hopeful, I think.
We have another comment, WADITY. We always did it this way. I'm going to use that acronym. Well stated.
WADITY. Sounds like a song.
Let's see, we have one more question, and if you have any questions and they weren't answered, make sure you get them in the Q&A as soon as possible, because this is the last one I have. Great presentation. We've struggled with calculating equipment uptime calculation, especially when corrective work is required, but does not affect equipment function. Cover broken, partially functional.
Right. Well, I would say in terms of uptime, is it usable or not? Up meaning you could it could go out and do the job that it's designed to do. There's still a little bit of gray area in there. You could, if you had to use a piece of equipment that's not 100%, but it would not be optimal. I think you could go either way, any way you want to on that. Make the gray area as small as possible, and just make a reasonable decision. And I don't think it's going to affect your metrics significantly.
And we had one more question come in right when I set the call to action. Someone's like, "Oh, I'm going to send my question right now."
Yeah.
He says, "I'm reading the white paper and find the last failure code confusing. No failure associated with the work order. The explanation: PM work order completed normally. PM work order could not be completed. Do all these codes apply to PM work orders as well as the fair work orders?"
Yeah. Well, the Canadians are giving me a hard time today. Yes, the short answer is These are intended to apply to both corrective maintenance and preventive maintenance work orders, CM and PM, because those are the two kinds of work orders that we do that are in which we're going to encounter failures. So we don't want, obviously, when there's a repair work order, almost all the time there's some kind of failure. So obviously we have to categorize that. But in PM, we also find problems, particularly those hidden or latent problems. And so capturing data from the PM work orders also, all of this is funneled toward the idea of knowing when things fail, however we learn about it, from a work order request or our own PM procedure or whatever. But somehow we've learned about a failure. We want to track that and distinguish whether it's PM related or not.
Thank you, Matt. Oh, we have two more. Someone says they would welcome any comment on reliability analysis as something beyond MTBF. Any use of MTTR?
So I don't know a lot about that, but I know there are some people who are working on those more advanced statistics, and I would love to learn more about that. In fact, I think there's some people in the VA who are doing some work in that area. So I will plead ignorance and a willingness to be educated.
Okay. We have another question. Great presentation. You were mentioning a common database that hospitals can use for their AEM programs. As of today, can a hospital include historical data from other hospitals in their AEM programs?
Answer is yes. The CMS and Joint Commission regulations are quite liberal in their interpretation of where you can get data from. And so, you know, any legitimate source is likely to be okay. I think your professional judgment is good there. It's a case too where you might want to, another application for your professional judgment is there something different about my hospital? Am I a rural hospital in the mountains of Colorado versus a big city hospital? Am I a children's hospital or a rehab hospital or something that makes me special compared to general purpose, general acute care hospital? So use your judgment, but I have not heard of any problems with pushback from the regulatory agencies. I'm going to grab the last 20 seconds and just say I've been kidding a little bit about Canada. I think some of you know and some of you don't that I'm actually moving to Vancouver, British Columbia, sometime probably this summer to do some work with Vancouver Coastal Health and some other organizations there, and probably have an office in Vancouver General Hospital. So I am practicing the difference between saying organization and organization, and I am trying to figure out metric temperatures so I know whether to wear a jacket when I go out in the morning. Hi. Done.
Okay. I know oh wow, okay. Matt, you're so popular. Do you have a minute or two to answer a couple more questions?
I am happy to stay on. I certainly understand if people need to drop off.
Okay, thank you so much. So we have another question. Great presentation. Do we collect the equipment utilization data in the CMMS? And if yes, how can we use the equipment utilization data in relation to equipment failure, trending, and analysis?
Now there's an interesting two-part answer to that. Do we collect equipment utilization? I don't think most people normally collect utilization data in that respect, but we can know we can know downtime, for example. We can know when this work order got started, when we took it out of service, when we put it back into service, from our start and closing times and dates in the CMMS. Not everybody uses that in a really, in a manner that lets you do good, close analysis. But I think there's some potential there for so following downtime, which is obviously the reverse of uptime. The only thing that you have to do is, you were saying, if something's down, if it's something that you need 24/7, downtime is different from, I had it down for 8 hours, but I did all the work at night when nobody uses the machine. So there are different impacts of downtime. So I think that I'll let that go. But there is a research project funded by the AME Foundation to look at the relationship between equipment utilization and maintenance requirements. And I'm an advisor to the fellow who's doing that work, and the theory is that equipment that gets used harder probably needs more maintenance, or conversely, if this is not well utilized and not heavily utilized, a small hospital that just doesn't use this equipment but needs to have this ventilator on staff, on the unit available, whatever. You can imagine the opportunity. When we talk about AEM programs and maybe backing off on some of manufacturers' requirements, we could say, if I know that this doesn't get used very hard, so I can be a little more flexible in how often I do the maintenance, for example. So it's research in progress, and I'm looking for good things to come out of that.
Okay, we have a few comments. One is pseudo utilization can be performed on infusion pumps with the manufacturer's data. Glass beam offers utilization on imaging equipment. So just wanted to add that comment.
Yep, we are talking to those companies, and we're talking to some healthcare systems that are willing to provide data. So good ideas, and we'll follow that up even more so. Thank you.
Let's see. We also have another comment. We are getting more utilization with Internet of Things systems. I look forward to seeing IHE data not connected yet.
Yeah, me too. As more stuff gets connected, I mean, there are good reasons to connect medical devices to the network, of course. But I think once they get connected, we're going to find lots of more information to share back and forth on the network, and have a lot of information that we can analyze. There are, for example, in the IHE, Integrating the Healthcare Environment project, there are already specifications for equipment to send maintenance related data, and potentially into your CMMS. And pretty soon the defibrillator is going to say, I don't know, circuit board 3 is not feeling so good, would you bring one up? And more. I mean, smarter comments than that. Not much utilization of that capability, but it's out there, and it's going to be exciting times over the next several years.
Okay, everyone, if there are no more questions, it seems we've reached the end of this truly dynamic presentation. I really want to thank Nathan. I want to thank PartsSource for sponsoring. It seems like you are doing some really amazing work for the field, and it is clear from everyone's response that your work is valued, and we are very grateful that you gave this presentation for ACCE today. Thank you all, and if there are no more questions, I hope you all have